So Unit 9 is going to be about probability. Now, probability is something that you may have learned before, so we're going to revisit that and then take it to the next level. So when we have probability, we have something that are called outcomes, or the result of something happening, like flipping a coin, and is like something happening, or a trial or an experiment, and the possible outcomes of that would be a heads or a tails. Now, the outcomes of rolling a dice are, we're going to assume it's the six-sided dice. We could get a 1, a 2, a 3, a 4, a 5, or a 6. So those are the possible outcomes when we roll a dice. Now, an event is an outcome or a collection of outcomes. For example, the event rolling an odd number, that's the event, and the outcomes of that event rolling an odd number are 1, 3, and 5. So the probability is a measure of the likelihood or chance that an event will occur, as shown in the number line below. So probability is a number from 0 to 1, but you probably don't think of probability like that. You probably think of probability as a percentage, or a fraction, and not necessarily as a decimal, but that's what it comes down to. Like, we know percentages can be rewritten as decimals, and fractions, if we divide out that fraction, that will give us a decimal. So we're going to be talking about probability in all three forms here. Now, when we talk about how likely something is, it's that probability is closer to 1, it's more likely to occur, but if it's closer to 0, then the event is least likely or less likely to occur, or not very likely to occur. So for example, flipping a coin, you see you have a 50% chance of a heads, 50% chance of a tails, so they're equally likely. The probability of rolling a 1 on a dice, that's not very likely because you have so many other options. And that's why we talk about weather. There's a 30% chance of rain, not very likely, but could happen, or there's a 90% chance of rain. So it's going to be very likely that we're going to get rain. So the theoretical probability of an event is what should happen. And we can calculate that by dividing the number of outcomes in the event by the total number of possible outcomes. So again, for example, if we're looking at that dice, and we say if I want the probability of rolling a 1, well, how many 1s are there on a dice? There's 1 of them. And how many possible outcomes there are? There are 6. So the probability of rolling a 1 would be 1 out of 6. And again, that's theoretical probability. That's what we expect to happen. So example 1 says you pick a card from a standard deck of 52 playing cards. Find the probability of these events, probability of picking an 8, a red king, a face card, or an ace, a 7, or an 8. So to help us with that, I'm going to show us the cards. So here we have a standard deck of 52 cards, and the probability of picking an 8, we got to see how many 8s we have. We have 1, 2, 3, 4 of them. So the probability of selecting or pulling an 8 would be 4 out of 52. And we can reduce that fraction to 1 out of 13. So if you wanted to write that as a decimal or a percentage, you can. I tend to leave them as a fraction because it's easier to write it that way, and you're less likely to make a mistake. All right, letter B, probability of picking a red king. So let's go back and look at our cards. A red king, so if we look at these, and how many red kings do we have? We have 1, 2. So we have 2 red kings. So the probability of picking a red king would be 2 out of 52, or 1 out of 26. Now letters C and D, there's 2 ways we could do them. There's a formula that we're going to learn later on in this unit, or we can think about these and say, well, if we want the probability of a face card or an ace, well, how many face cards are there? We have all these face cards here. So that's 12 face cards or an ace. So in total, I highlighted 16 cards. So the probability of picking a face card or an ace is 16 out of 52. And again, we can reduce that to get 4 over 13. All right, then letter D, probability of a 7 or an 8. So if we go back here, the probability of a 7 or 8, we have 4 7s and 4 8s. So together we have 8 cards, or 8 successes, or 8 desired outcomes out of 52 total. So 8 out of 52, which is going to give us 2 out of 13. 2 over 13. So when we look at these, you can see that picking a face card or an ace is more likely than picking a red king, because the fraction is closer to 1. So on the next page, it says your friend rolled a 6-sided dice 225 times. Based on the theoretical probability of rolling a given number, how many times did you expect her to roll a 2? So first we would take the probability of rolling a 2. Well, there's 1 2 on a 6-sided dice, so the probability of rolling a 2 is 1 out of 6. So we would multiply 1 out of 6 times 225. So 1 divided by 6 times 225 gives us 37.5. So we would expect about or around 37 times. So then letter B, rolling a prime number. So how many prime numbers are there on a dice? So as a reminder, we have 1, 2, 3, 4, 5, 6. Prime numbers are numbers that only have 2 factors, 1 in itself. So 5 is a prime number. There's only 2 numbers that you can multiply to get 5, 1 and 5. 4 isn't, 3 is prime. 2 is prime, even though it's even. It's the only even number that's also prime, because the only factors of 2 are 1 and 2. 1 is not prime because 1 only has 1 factor, not 2. So there are 3 prime numbers here. So the probability of a prime number is 3 out of 6, or 1/2. So then we would do 1/2 times 225, and we get 112.5. So around 112 times. If you rounded that up to 113, that's fine too. But we know we can't have 112.5 times. You can't have half a success. Now a 3 or a 4. Well, a 3 or a 4, that would be 2 out of 6, or 1/3. So 1/3 times 225 gives us 75. So 75 times. You would expect to roll that. So this gives us a good segue into what's called experimental probability. So theoretical probability is what we expect would happen. What should happen if we roll the dice 225 times. Well, we should get a 3 or 4 75 times based on the theoretical probability. But I would bet you that if you were to actually roll the dice 225 times, you would not get 75 3 or 4s. You might get something a little bit different. That would be called the experimental probability. What actually happens when we carry out an experiment. We had talked about earlier how flipping a coin, we say you have a 50% chance of heads, a 50% chance of tails. Now, if I flip a coin 100 times, we will most likely not get exactly 50 heads and exactly 50 tails, because probability is, again, a complicated topic, because your experimental and theoretical are going to get different values. Now, if your sample size is large enough, then you may get really close or exactly to your theoretical probability. If you flip a coin 4 times, it isn't likely that you're going to have 2 heads and 2 tails. But if you flip it 1,000 times, then you'll get closer to that 50% heads, 50% tails. The more trials you have, the closer it gets to that theoretical probability. So then we can calculate the experimental probability by performing that experiment and looking at the event. So we have exam grades of students in a history class are shown in this bar graph. Find the probability that a randomly chosen student in the history class received a C or better. So we need to figure out how many students are in the class altogether. So we have 3 that earned an F, 1 that earned a D, 8 that earned a C, 12 that earned a B, and 7 that earned an A. So if we add those up, we get 31. Now we got to figure out how many earned a C or better. So that's 8 plus 12 plus 7, which is 27. So the probability that a student earned a C or better would be 27 out of 31, which would be approximately 0.87 or 87%. So the big idea for this lesson is that probability is calculated by dividing the number of desired outcomes. What are we looking for? Are we looking for drawing an ace? Are we looking for students that earned a B? Divided by how many possibilities there are. And then you have theoretical probability, what should happen, what we expect would happen, and then we have the experimental, what actually happens if we run an experiment. So that's it for this. Thanks for watching. Make sure to like and subscribe.